Hello everyone, in this recording we're going to work through another example of the general update pattern. We're going to work through making this animation. So not really a data visualization, but it will give us some more practice thinking about how does D3 do enters, exits, and updates. So why will we need those? Notice that the circles are some of them are being added to the page at any moment, some of them are being removed, and all of them are changing. We can actually see this in the HTML source. So if I go to the original, right? So here's the SVG, and then these are all the different circles. So I'll start it off fresh. So there are not too many circles, and then a lot of the circles are being added. Some of them are being removed, and then the radii, these radii are all changing at every moment. Right? So how do you create this sort of dynamic document? We'll see. So first things first, we're going to need some sort of data array that's going to keep track of all the circles. So at the beginning, the array is empty, and then at each moment, we're updating it. So we're going to have the x and y coordinate for each circle. We're also going to have the radius. And the radius is going to be changing. Right. We'll have this whole array of objects. So this is the function that I use to create a brand new circle. So remember when it's at each moment, you might create a new circle, and then it's going to be growing over time. To create a new circle, this is the function. So width and height refer to the width and height of the overall canvas. Radius is what's the largest circle that I'm allowed to create. So here, this is a random number generator, just like we've seen in other places. This is giving the x and y coordinates along with the initial radius. So all the circles, they start with radius 2. Different circles have a different maximum radius allowed. So if you look here, some of them are allowed to grow really large before I remove them. Some of them get to some middle size, and then I remove them at that middle size. So that maximum radius is also random. And then this rate is saying how quickly is the circle going to be growing. Right? So some of them grow really slowly, some of them grew really fast. So this is some number. 1 is just going to mean like the baseline rate of growing, and then it's going to be kind of between 0 and 10%, the speed at which it grows. Okay, so those are all going to be in one big array of objects. For the ones that are already created, we're going to want to update them. The way they're going to be updated, their radius is going to be changed. The way the radius is changed is I'm taking the current radius and I'm multiplying by this rate. So if the rate was 1.05, then between each frame of the animation, I'm taking the previous radius and increasing it by 5%. So that's all. What this function is all that's happening between one frame of the animation to the next. So we're adding we're adding one new element, we're changing its size, and then the last thing, if it got too big, if the radius got larger than the maximum radius, we're removing it. Right? So its filtering is keeping only the ones where the radius is less than its maximum radius. So aside from visualization, aside from any rendering on the HTML, this function is creating this array that's growing, shrinking, the properties are changing all the time. So this is some sort of very dynamic array, and we need to be able to reflect that in the visualization. So yeah, this is just the for loop that would update. It would add 10 circles. It would keep on changing the sizes at each iteration. Okay, let's actually visualize it. So in the very beginning, we'll create the data bind. So we're selecting all circles. This is going to be what tells us we need to start appending some circles. The data that are used are going to be in this ring. So I'm going to use the join operation that briefly introduced in the last recording. So the way join is going to work, it's going to keep track of all the entered elements. So these are new elements in the array that weren't previously there. So the new elements, these are going to be kind of everything that's coming from new point. When we append it, we just append it at its x and y location. So this is the initial location for that circle. update, it's looking at everything that was already there, and I want to change its properties, so I'm changing it to its radius. And then remember, if a point got too large, we removed it from the array. So that's going to appear in this exit. Okay, so this is going to be whenever you notice that there are more elements in the array rain than there are HTML tags. Okay. So now I have this update viz, which is 2 steps. First, I'm updating the data in rain, and then I'm updating the attributes of all these circle tags. Right, so this is just like what's going on here. All this manipulation on the circle tags is being done by this join. Right. So once I have this function, I'm just going to call it every 100 seconds. Or sorry, every 100 milliseconds. So this looks like a very clean implementation, and it almost works, but not quite. So actually, before even looking at the reason, notice just this. This is the plot. This is the visualization that you would get if you use the code above. And do you see what's going wrong? It's doing this kind of weird flashing kind of thing. It looks like for some of the circles, the radius is getting really big, getting small again. It's not just increasing and then being pulled away, right? So what is going on? The issue is it's like this, right? The way that we've bound the data, D3 has no way of knowing which element in the earlier array matches which element in the modified updated array. Okay, so think of it like this. So in the beginning, we might have had an array that looks like this. Each entry in this array would correspond to one circle. Some of the circles will have grown too large. These are the ones in red. So these are the ones that will be removed by the filter command. So the array gets smaller. But then instead of realizing that this last element was not removed, so this last element should actually be here. But instead, D3 is just looking at the indices in the array, and it's just thinking like, since this array is longer than this one, I should just remove the last however many elements that no longer match. Right? It thinks that we removed these elements, even though we removed the ones in red. Right? So since there's a mismatch between what D3 thinks we're removing and what we actually wanted to remove, it's creating this kind of mismatched transition. Right? This element in the top array doesn't actually match the element in the bottom array because we've kind of sliced away intermediate elements in this filtering step. Right? So we need something new in the way that we bind data. We can no longer rely on indices, which is how typically when you just bind data using the default, it's always going to bind it using indices. Fortunately, there's a very easy mechanism to deal with this in D3. The idea is to just create an ID. So if you can associate each of these array elements with an ID, then you just have to have the same IDs appearing in the updated array. So if I tell it, like, this is circle number 1, this is circle number 2, and if I remove circle number 5, then in this array, it's going to go from 4 to 6, right? Or 4 to 6 right away. And then it's going to know to match circle 4 from the original array with circle 4 in the new one, and circle 6 in the original array with circle 6 in the new one. And so we need to have some sort of index. And now it's actually recognizing the correct associations, and it's actually removing the ones that we wanted to remove. Okay. So to do that, we need to create some sort of attribute in our objects that's going to be used as an ID. So here I've just indexed anytime I generate a new point, I'm taking some global ID variable, I'm incrementing that ID variable, and I'm storing that unique ID for each circle. Now, when you have this sort of array of objects, you can look at the object properties and use that to define an ID function. So that is always the second argument for data. If you don't include the second argument for the data bind, it's just going to assume the indices are enough. But if the indices are not enough, you can always provide a second argument, which is this ID. Okay, so that's it. That's enough to create the more smooth visualization. So you've seen we're entering when we add the new element in the array. We're able to change the radii gradually by doing this update. And when they get too large, we exit it, and we make sure to exit the correct one by using the ID function.